to simplify this rational expression, we're going to go back and use something that we've probably seen before, but just in case. If it was something simpler like this, x to the fourth over x to the second, we'd say the final answer, actually let's change that, let's say x to the fifth, just so there's, I was thinking about a way a student might get confused there. X to the fifth over x to the second, that makes x to the third. Because when you have the same base, the powers subtract. Okay, when you're dividing. If you have the same base and you're multiplying, it's different. That would make x to the seventh. Okay, but we're not multiplying in this problem. So what I see here is I have x to the third over x to the second, and it's all next to all these other terms. We can just subtract these because it's like you could separate them into three separate fractions. X to the third over x to the second, that makes x to the first. And then we have 2 over 6. If you do 2 divided by 6, that's the same as 1 over 3 if we simplify that fraction. And you got y to the first over y to the fifth. If we subtract those powers, 1 subtracted by 5 makes -4. So the final answer, if you're using a program like MyMathLab or whatever they call it, they're probably going to want it like this. The x is a positive exponent, so I'm going to put that in the top of the fraction. The 1/3, it's like I put the 1 up top and the 3 on bottom. And it's y to the -4th, so I'm going to make that a positive exponent by putting it in the bottom of the fraction.